Okay, so while you guys are making the Bohr models on page 33, I'm going to skip ahead to page 34 and just talk a little bit about how the periodic table is organized and what the family and groups are, how they're named. So we know that the periodic table is organized by increasing the atomic number. And it increases from left to right. So starting with hydrogen is 1, and helium is a 2, and lithium is a 3. And it goes up as we go down periods left to right. And the elements become less metallic as we go from left to right. So way over in family 1 on the left, the family 1 elements like sodium and potassium are described as being very metallic. And as we go all the way over to family 8, neon and argon are, which are gases, so they're very non-metallic. Okay. We know that the columns are called groups or families, and we know what those groups or families have in common is that they have the same number of valence electrons. The rows going across, we've already explored this, are called periods, and they correspond to the energy levels in the atoms. Okay. The elements on the periodic table are broken into 3 main groups. The first big group are the metals. All the metals are to the left of the staircase. The inner transition metals are those 2 detached rows that look like they're cut out. The transition metals are the ones that are in the middle in families 3 to 12. A lot of times they say B groups. The nonmetals are to the right of the staircase, except for hydrogen, which lives over in family 1, but we know hydrogen is a gas. And the metalloids is the third big group, and they're the elements that are touching the staircase, and their box will touch 2 sides of the staircase, except for aluminum, which is described as a metalloid by position, but we know that it's a metal. Now let's take a look at this periodic table, and this isn't as complicated as what this sounded. We said the metals are left of the staircase. So here's the staircase. Everything to the left, except for that hydrogen, is a metal. That includes, over here to the right of the staircase are the nonmetals. So that was the second big group. Now we said these metals are in the nonmetals, in between them, right along the staircase, are the metalloids. And I said here it would be touching 2 sides. So like silicon touches 2 sides of the staircase, germanium touches 2 sides. So it's these boxes that touch 2 sides, except for aluminum, which is a metalloid by position, but we know it is a metal. Included in these metals are the transition metals right here, that are in the big group of metals, which is what we said. And then these inner transition metals, which are these 2 detached rows. Now, normally we don't look at the periodic table like this, but these detached rows, remember I said that period 6 goes down to the detached row and then it's stuck in here. Well, if we glued it all back together, this is what it would look like. So I kind of wanted you to see how that works. And then this is the diagram we've been using to put the electrons on the Bohr model. And it really corresponds to the position the elements are in on the periodic table. So here we know that the first energy level is the first period. So right along here on the first energy level, the first period, we have 1, 2 electrons if we get to the end of the first period and it's full. And then the ones I put in orange are the 8 electrons that can fit on the second period or the second energy level right here. And then these electrons on the third energy level go right here. And then if we're following the chart, we come to these 2. It says it would be on period 4. You look down here, and I colored 2 of them yellow. And then remember we said these B players, these B groups, okay? Their electrons are down a level, so those are the transition metals. And we come back to these 6 which are red, and we follow this on down. And the 2 groups of 14 that the inner transition metals, their valence electrons were way down below, and they were really changing out. So we transition from 2 valence electrons to 3 valence electrons. Okay, So when we look at the periodic table pasted back together, we said that the metals on the left, so the most metallic things are over here, francium. The metalloids are right along the staircase. It's the elements that touch two sides of the staircase except for aluminum. The nonmetals are way over here on the right side, except for hydrogen. Transition metals are right here. And the inner, kind of in between here, are the inner transition metals. We were glue the periodic table back together. And you can see it makes it really long and skinny, and like the boxes are too small. So they cut these out and stuck them down here so that it would be easier to read. So it usually looks like this. So we're just going to take one more chance to look at the periodic table and label it. Metals are found to the left of the staircase. Transition metals are in between. Nonmetals are right of the staircase. Metalloids are along the staircase, except for aluminum. The inner transition metals are the two detached rows. Okay, so we're going to label the metals, the inner transition metals, nonmetals, metalloids, and the inner transition metals. Okay, these are the metals, everything over here to the left of the staircase except for hydrogen. The inner transition metals are right here, they're kind of in between. The nonmetals are over here to the right of the staircase, and don't forget about hydrogen, it's a nonmetal. Metalloids are right along the staircase, everything that touches two sides of the staircase, except for aluminum. The inner transition metals or rare earth metals are down here on these two detached rows. And then the families have special names, and you need to write these in your notes. Family 1 called alkali metals. And it didn't include hydrogen because it's not a metal, it's a gas. Family 2 are called the alkali earth metals. There's only 4 families that have special names. Family 7 over here are called halogens. And then these very non-metallic things are called noble gases. I wanted to take a look at a couple of the homework assignments and make sure you're not getting stuck on anything. This first page is pretty obvious. All you got to do is look on the periodic table and find elements with geographic locations. Because this is completely free form, I put a link down here to check your answers. Make sure if you're not finished with something that you save it for later. This page here too is pretty straightforward. I'm going to list the names of elements named after famous people. They're definitely going to look like people's names, okay? And then you put in the symbols for the elements here, and you're going to write in the element names here, because quite a bit of this top part is free-form answer. I also put a link to the answers here. Also, when you finish, it'll show you which ones of these element symbols you got right. And this was a review based on the reading of who discovered which parts of the atom and in what order, the atomic models. Okay, on this page, and I filled this out wrong on purpose so that you could see how it works. It says show the right answers. So I click on this and it shows me the right answers. So you can check your work. If you want, you can repeat the exercise. So down here, it says I need to repeat the exercise. Okay, the first person to suggest that the atom contains smaller particles was Democritus. And you would fill this out. Now, on this page, okay, I explained this in one of our Zoom meetings, but in case you weren't there, okay, I put these red lines at the top, and it shows the atomic number, and we know from our notes is equal to the number of protons. So I'd fill this in, and that would be a 2. I also know that the atomic number tells me the number of protons, but the positive protons is always equal to the negative electrons. Now, I put these formulas up here at the top of the page. The mass, which is 4, minus the protons, which is 2. Well, 4 minus 2 is 2. So you would fill that in. Okay, same thing with this one. We know the atomic number. We also know the number of protons. We know the number of protons. We also know the number of electrons. And then you know that the mass of an atom in the nucleus is 12 plus 12, so this would be 24. Okay? And you're going to go through and fill this sheet out that way. On this one, okay, you're going to look on the periodic table. You're going to find the symbol for lithium is Li. And then you're going to Li. And then you're going to find the atomic number for lithium, which is 3. And you're going to find the atomic mass, which we're rounding it off to 7. And you're going to look. You know that the number of protons, that's why I put this up at the top of the page, is equal to the atomic number. You also know that that's the number of electrons. Find the number of neutrons, you take the mass minus the protons. 7 minus 3 is 4. And you're going to go ahead and fill this out. Okay. On this one, okay, you're going to look. The period tells you the row. So calcium is on the 4th period. We know from our notes that that also equals the number of energy levels. We see the calcium is in the 2nd column, so it's in the 2nd family. And that means it has 2 valence electrons. From the notes, you know that 2 valence electrons are going to be represented by 2 dots in the diagram. This one says to look at these models up here and answer these questions. It's pretty straightforward.